Welcome back. So, I've spent part of yesterday and most of today looking into things around the Great Lakes, Canadian Shield, in terms of any videos I could get on YouTube by doing a search like this. I have not watched this one. Not watched this one. This one looks more like footage. But I watched this one, which was about. I mean, it's kind of. I'm not sure what it's from. I don't think it had the intro. Drain the Great Lakes, it's called. But it had pretty good scientific data like this. Waterfall here that fell there over the top of this is the interpretation, which maybe it sounds plausible, and they're pretty much just explaining why certain interpretations exist. There's this going on down below in one of the lakes. I want to say Erie. I want to say this thing. I believe this is the sandbar, but maybe not. That at some point they talk about it. Yeah, this Niagara Falls. I'm like, oh yeah. That's part of it. It didn't like click. It's worth like noting. It's part of it all. But then there are other falls apparently in other places. Other things in this one. This one was interesting because I never saw the Neil Adams video. I was like, Neil Adams. I've seen who's the Expanding Earth videos. I've seen the whole Earth, but I've never seen just this much. And he's basically saying they pulled apart and then a gap formed between them, and then it compressed to a degree also. But ultimately, I'm not sure if he said compressed at all, honestly. Just expanded. I think he's just saying expanded. He's probably just trying to explain the Earth expanded and just thinking about it purely expansion based. This one, I'm trying to think what it was about. I watched this one. I don't remember the talking points, things to do with just the sheer amount of water in the present. Possibly other things. This is the Niagara Escarpment, which sounds like it's a drop off. Like a ridge, I guess, a cliff that takes this shape. So there's some kind of like platform here that has at least like this portion. It goes maybe over across even further relatively, but more subtly maybe. Or turns something where there's like a shape here that has, or it's just lifted, maybe it's slightly angled. So there's that. I did not watch the Finger Lake one. This one, which is about the mid-continent rift system, which is this white thing. So it's not in the shape, interestingly, of the escarpment at all. Like, it would be maybe make sense if the escarpment was here, but it's actually not. Something of note, but it goes up this way, it goes over and around, it goes down here through Michigan. And this is a rift zone that's interpreted. I'm saying interpreted because it's a little odd, honestly. Interpreted to be 1.1 billion years old. So that would mean it pre-existed the expansion of the Earth. But I'm fairly certain it's this. Like, this is part of it right here. I know this is part of it here. And then maybe it's there with some, like, to here. But, like, clearly it continues. I guess here there's just a rift. An actual detectable separation in the crust that occurred. But it's dated to 1.1 billion years. Began to split apart during the Mesoproterozoic. Rift failed. Buried beneath later sedimentary formations along most of its western and eastern arms. And then those arms meet at Lake Superior, which is contained within the Rift Valley. So Lake Superior is rather unique amongst the Great Lakes here that also include these ones, in that it's like within this rift zone, so it's the deepest lake in North America. The lake's north shore in Ontario and Minnesota defines the northern arc of the rift. From the lake, the rift's eastern arm trends south to central lower Michigan. So like this way, I guess. Possibly to this like focal point and through it. Yeah, this image. This is the rift. This right here is definitely this here. Sleeping giants. Okay, so I tried to watch this one, it was just kind of text. This one was showing past shorelines. I think it was actually, yeah, it was like flyover, like shoreline. Leading up to the present shoreline. Okay, so I took a bunch of notes. The Keweenaw Peninsula. This peninsula is where most of the copper in the United States is mined or sourced. There's also copper here, and this is a sacred island. I forget the story exactly, but copper in this like tab thing. Something of note that there's copper involved in the way this is. Just thinking in terms of like atomic behaviors that maybe are exemplified here. I don't know what that could point to, but just something of note that there's like this concentration of copper there. Superior Lake is too deep. I don't know why I wrote that, but it's very deep. It's too deep for the glaciers to have caused it. That's what it was. So, like, it's anomalously deep. I think they explain it by the material being sandstone, and, like, so therefore it could, like, gouge deeper, and just the rift being present. But I think the general consensus is that the glaciers presumably could not have etched that deep. This I found interesting. Analyze shells from the bottom of the ocean to infer the amount of ice on a planet. And I don't know, it was not one of these. It was an actual one about a lecture. This one is from this video. He said, they analyze shells from the bottom of the ocean to infer the amount of ice on the planet, and I think it's from benthic something or other oxygen concentration. Which, if the Earth is supernovaing in its fractal way, it makes me wonder how like true that method is. It kind of assumes some things, I feel like. Okay, Pleistocene had repeated growth decay. So this is all from this lecture. Pleistocene had repeated growth and decay of the large ice sheet. So I found that interesting. The term decay in reference to the ice sheet that was present up here, where it's growing and decaying, maybe radioactively, even in a way that's like reflective of how atoms function. I don't know. Most records of glaciation are just from the last glaciation. So that in reference to the oxygen isotope concentration measurements from the shells in the ocean, which is interesting that geological processes are tied to shells in the ocean. Almost as if they are the result of geological processes, as crazy as that sounds, many times at least. Most records of these other inferred glaciations don't exist, and all that exists is from the last glaciation, which kind of to me implies like a more continuous process, that we really just saw the end of it, as like maybe not even glaciers, probably glaciers, but like definitely more of like a huge ocean than is being recognized. Like the water below the ice is not being accounted for nearly well enough to like see it as an ocean mentally. Okay, the landforms we have today. Yeah, the landforms we have today are mostly records of the last glaciation. Lakes eroded over 2 million years by multiple series of glaciation. So these lakes are considered to have formed over the last 2 million years by erosion. There are 4 episodes: the Wisconsin, Illinoisan, Nebraskan, Kansan ice sheet glacial episodes, which apparently only the Wisconsin. I think I said it right the first time. I'm close enough. Lack data prior to the Wisconsin. Canadian Shield, Great Lakes either on Shield or either on Shield, so the Canadian Shield is really apparent. It basically, its boundaries are where the lakes are, like where they're most populated, where they're most dense, rather than where they're not. So there's like a boundary of the Canadian Shield, and on that Canadian Shield, the Great Lakes are either on the shield or just next to it. So like these lakes are essentially like along the boundary. Like some lakes here, but that's like within this. And then over here, like here, not part of the Canadian Shield, part of the Canadian Shield, like it cuts that in half. Same here, really, where it splits this one. So it's kind of like, to me, it's almost like a staple that physically conjoins like a bond. Like I'd be really, now that I say that, I'm very curious if there's like a lower depth, medium depth kind of thing, where there's almost like a staple shape. I think this is called something Bear, Big Bear, Great Bear, Great Bear Lake Tip. It does kind of have it on the bottom one. Let's look at that imagery. Like that's the deepest here. That's the deepest there. Not so much on this side. Maybe it's the inverse, where that's like the shallowest there, and that's like the shallowest there kind of thing. $300, $135. $34, and then like right there is seemingly in like the 50 to 20 range, I guess, relative to its surroundings. I don't know, just a thought. Like, it kind of makes sense that it would have like a positive, negative, or positive, negative, depending on angle of perception. I mean, it's not happening everywhere, But just the thought, I don't know why I would be doing it there and not like further south. Maybe because there is actually much more like accreted material. So, or close to it, like here. I'm not sure exactly where the accreted material is. It's probably here though. Or here. Not sure. But almost in a way like connecting the Canadian Shield to this snake portion here, which is then connected to the Columbian River basalt and to this other snake one energetically in ways to like coalesce or conjoin, bond the North American continent as we see it today. Okay, let's see what else is up. Just some thoughts, of course. Differential erosion of the shield created most of the small lakes, either because of bedrock variability or structural weakness. So in the case of here, like there's structural weakness, but in general, it is suggested, at least. I'm trying to think of like how reasonable it may be. Like, essentially, my thought is these show current flows. Like all of these patterns, like here, like this is a current flow. It's not like going here necessarily because of the material that's there. Like it's going there because that's the angle that the pressure is pushing it in. So it flows, or vice versa, seemingly this way because it looks like it separates. Unless it's converging. But it's got this huge like field going on. We see all these lines going out at different angles here, which I really think is related to the Earth's expansion process, like inducing these currents, this current here going across here. Like these features are forming during the Earth's expansion process. So for there to be anything that's dated otherwise is rather odd. We'll see what else, if there's anything else, but this is 1.1 billion years, which really is before the Earth expanded. And is present here. So it's in the magnetic anomaly map, which is the result of the Earth expansion process. It reminds me of one other anomaly, Hare Valley Range, this one, which I have associated closely with Earth's expansion processes, but if we look at the geology, initially during the Air Valley, passive rifting around 2.5 to 2 billion years ago, active rifting 1.9 to 1.6. .2, like this is anomalous. This one, less anomalous. Everything else is anomalous. To a degree, like it may be that it's just pre-existing things there, but like that there are dates to these time frames need some type of explanation besides like a sequence of the Earth expanding. Like it needs more than that. There's some sequence of expansion that's happening. Just trying to think what. Does this go there? No. Okay, let's keep going. Just note the anomalies. It's not like the end all be all of things that there are anomalies. Like, that's how it goes. That's how theories get rejected, though, is they run into anomalies that are not easily explained. And then some other explanation arrives that, like, explains that thing, but it doesn't explain a lot of other things that need explained. Like, for instance, that classical mechanics was usurped its position of, like, the consensus theory for three alternative models that, like, required one another, essentially disregarding all sorts of evidence because anomalies arose that the theory at first glance couldn't explain, but really it was just because there weren't enough details accounted for. Same thing here, where like I'm not sure what's happening, although this is giving me the way that arc is and the way this is giving me vibes of like this region. Like maybe it started out with like the Mariana Trench even forming there as that arc, like contributing to that. I don't know why. And then this shape like formed there, but then it here, but then it moved to over here, and then ultimately like moved down to where it was then coming out this way. Started this way. No, started. Mariana Trench would be on coming in this angle. That current would be coming in that angle, so it'd have to be like north or north south. I'm not sure what. Let's say Earth 550 MA. That's gotta be the Hudson Bay there, Greenland. So it's kinda seems just opposite, but oh wait, here we go. Hudson Bay, Mexico, north-south this way. possibly based on data. I mean, I'm just looking for one that at least like gives an indication that maybe that is a thing, but this one's opposite, like it's north-south. Let's see, orientation of Laurentia. Maybe. Sure. Is this it? It's gotta be it. We just need a map. Equator, basically, there. So it is going off like a 90-degree difference. Okay, okay, good. It's possible then that the current that went into the Mariana Trench and interacted underneath Australia, mostly, like more so under Australia. It's possible it started out over there, influenced like the terrain above, and then moved over, or maybe it just had like two opposites, like a negative in that it was cold, like glacier, and then a positive in that it was like magmatic, hot, and then a separator of maybe like the boundary of Laurentia. That's once it formed the separator, it disconnected the two. It's almost like a positive and negative in between it was born. The Bighorn Mountain as like the focal point. Which I believe was like over here. Based on this dragon form here, we have this curve going this way towards Bighorn. Let's try this one. This curve going towards Bighorn, not like reaching it. So Bighorn was basically like relatively here. Not actually at that position, but in that pathing. Although maybe it initially was at that position. And like it was separating. It's definitely a path here, and then like a somewhat wall here, although this might have came across here. Like this current ended up focusing through this channel. Until it built up a wall enough to block it off. And then another current crossing it, creating a bunch of eddies. Maybe. Going here, oh, going across and around and below. Oh, there's like a yin-yang thing where it did one of these, maybe? Oh, they're not visible there, I guess. This is not the same, I don't think. Current comes in, it definitely bends and goes across. And then it clearly, even though it just goes across, has an interaction pushing back that made it go like this way and build a wall here. So there's no way that there's just no way that the mid-continent rift is dated accurately. There's no way. It's gotta just be that it's like the materials are dated that way. Some other reason that it's being miscalculated. Because it's literally, there's no way it didn't form in this overall process. This here formed in this process. It wasn't like sitting there. Like some pre-existing mound that this current went to, maybe? I mean, that's the only possibility, is that there was a mound similar to like over here that is really hard to distinguish that it was there because it's kind of like the previous glacier. Like the only one we see is the most recent, this large system that's just like very dense with a cross current. And current went around it here and under it and interacted with a current coming from over here that went down and created vibrations down at the East African Rift. So I guess it's possible there was a pre-existing system that this current just went to and then kind of wrapped around, because it's like those, like a trampoline with a heavy ball on it, and like those demonstrations of gravity that I don't really like very much. Like, you know, like there's the two-dimensional guys, there's three dimensions though, at least. Anyway, this goes across though, goes down around it maybe. Like it's, I guess it's feasible that there's something of that nature happening. And then cuts across it, but then it still forms like a wall here. Maybe this pressure comes in, builds this wall, and then pressure flows in even more to just kind of block the current flowing in. down here going across and interacting with the current coming up this way. These currents. Which then maybe leads to just like material being pushed out here into the current that then gets shoved against the resistance as that dragon, as the mid-Pacific Mountains, maybe. Since it would be kind of coming in here, like at this width. Also over here. So I guess it would go up and around it too. So then another current crosses with. Down this way, and then down and around this way, feeding materials into the dragon at those points, and then it kind of gets stuck up against the resistance, but has these like connected structures. This one's got little ones this way. I wonder how well that aligns. These look pretty different angle. Where this is like this, and then if anything, shallower of an angle. I guess it could be this one here. Would be coming off of this side. So I guess that could kind of stuff going in here, down here, into here, and across. But this is going this way, so it's pushing a swirl here that's then putting currents this way. Which is not over here, but it's here. Feasible. I'm feeling pretty good about those additions to the potentials around this. Okay, so we got a current coming through, interacting with may or may not have been a pre-existing system, because it looks like it went into it, through it, up and over it, and around it, and below it, and past it, as well as around it. Although this current probably held this more so. This is bouncing off of the pressure here. There was so much pressure here from the swirling currents that it literally deflected off across this divided current going this way. Like, I think that makes sense then. Then whatever is flowing this way, it flowed this way. And down here, down here, across, and met resistance here. And then over here, there was probably another, this here, meeting resistance somewhere. Over, was it there? This goes here, but then if we continue over there, there's like this thing. It's just not on a pre-expansion Earth, so it's a little off, so it's hard to say. Except for things that I'm like focusedly aligning. These things are pretty off. This is pretty off, it looks like. Maybe not. But it generally points back to there, actually, just looking at that. That's real in line. And then let's say this here. I mean, it's not exact in this, but is it over? Maybe like a furthest width to this side relating to there, and then the furthest to the bottom side going into that one. Okay, let's see what other details we got. So the Canadian shield is much more heterogeneous than the platforms. So like, this is very relatively homogeneous. Like, this is relatively homogeneous, but this is very differentiated, heterogeneous. Compared to over short distances, at least. So like within any given location, there's a lot of variation in what's present, it sounds like. Whereas over here, like within a region like here, it's like pretty much all the same material, relatively speaking. Which made me think of something almost like a galaxy with many stars, like something much more infinite than one. Like if it's towards an end, there could be like a singular system, like Girnar, maybe, even though it's not really a singular system, but like something that's a batholith that's like composed of one material, just homogeneous, which is kind of like it's one thing, whereas this area is much more like it's many things, so it's more towards the like universe side of things than towards the like star side of things. But then there's differential erosion of the shield is said to have created most of the small lakes, either because of bedrock variability or structural weaknesses. So again, like whatever is happening here is the expansion of the Earth process. So it's very odd that there is this differentiation where there's like, this is gouged because it's made of a softer material. Like, how did that softer material was it before the Earth expanded? I feel like these structures are not pre-Earth expansion. Unless it just like preferentially use them as paths, which is possible. It's possible. I don't know. This area is complicated. Okay, let's say page page de Lake Superior formed due to failed rift that filled with sand, making it sandstone but not well formed, and it was easily eroded. Okay, that's this one again. I've already talked about that concept. Whether or not that's exactly what happened. Certainly there's some kind of rift zone going on. Drift found mostly outside of Canadian Shield. So we're still going over details from this one, where the drift is mostly found like out here, relatively speaking, or maybe in a bit, but like not found on the Canadian Shield itself. It's kind of interesting, like the drift is only found at the outer edges. It kind of makes me think of centrifugal force. Centrifugal? Oh my god. I'm like, wait, is it centrifugal?
Centrifugal force.
I know I'm good at things. You guys can understand. But like, what's it called? The separator. Centrifuge. Centripetal, that's the one. This thing. So the pellet might just be an added thing. Stands for the concentrated particles in a tube. Okay. So basically it's taking perhaps the most dense materials and putting them towards the outer boundary relative to the axis of rotation. I'm just trying to figure out if it's densest. Dense. Based on their density. You get the point. I'll stop looking so dumb now. Okay. But the drift, I mean, if there's a spiral of like current going on generally here, that has like a center, eye of the storm kind of area that's really putting pressure outward on currents flowing in, but it's contained to just stay there, then it would take drift and like distribute it towards the outer edge. Okay, that's cool, that's cool. That's a thought. That kind of makes sense to me. Pre-glacial drainage network for upper Mississippi went east. Wisconsin River. This went eastward. Or here? I guess now it goes westward. Kind of brought to mind the concept of things reversing. Like, when the process was happening, there was so much pressure that it was converging and, like, upwelling into things. Like, water going uphill, basically, and leading to channels that are carved that then, once things like pressure recedes, then those same things that are lifted high like fall back down like a river. That's kind of what it made me think of. That maybe there was actually scientific evidence in the Wisconsin River of this, like, change in the direction of the current flow in a way that's not found everywhere. Maybe because of the just, like, high current flows that were present. No Cretaceous shale existed in Lake Superior because they looked for it. At least in the samples they took, which was like 5 in western Lake Superior. I think that driftless area may owe its presence to Lake Superior. Someone suggested a possible connection, like, because current flows are going this way from Hudson Bay and then, like, going down and getting trapped here. That they protected this region where the driftless zone. I'm not sure. I mean, now that we just figured out how drift is moved, it does kind of make sense that it would, like, the drift that should be over here is in here, but I think the driftless zone is smaller, like, it's, like, here, maybe over here. Like, this would have blocked drift over here, too, and over here. I guess maybe just the angle, like, some drift perhaps came across this way, and anything this side couldn't make it into there, and then also came across here, and it just blocked the whole width. And then maybe another path, like, coming down this way, running in here and blocking something. Let's see where the driftless zone is exactly. It's certainly bigger than what I was just kind of blocking, is like over here. Down through Illinois, even down here. I guess here, like, kind of there. I mean, it's possible that it's related to some kind of drift that was coming, like, going around, and in, and then out this way. Like, I've been kind of thinking about recently, and going across here, creating this, going out here, going out this way, but also going over, like, creating a boundary this way, going more towards the Appalachians and, like, having them as a wall to kind of hold the current over on this side of it, and then basically deflecting this current back around this way, but creating, like, a wall here that maybe goes across, like, this far, and, like, this path, this width had drift that reached over here, but not in here. But it went, like, still there, just to here instead. That's possible. Maybe there's no drift in the Canadian Shield because it ran out. Like, it kind of like if you run one of these for like a split second versus running it a minute and 30, like it has time to separate. So the process was going on long enough to remove all of the drifts from the region. I wonder if there's even like rings of drift of different like average radius things that aren't really considered drift, like more subtle things. I don't see anything in the map. Okay, this I found interesting. Okay, softer bedrock. Okay, again, ice sheet retreat rate did not speed up around the younger Dryas, but thicker Varv deposits formed. Varv geology, let's say, just in case. Varv, meaning layer, pretty much. It was just layers that got thicker. Like they were like much more intermixed materials, and then just these thick layers that happened at the younger Dryas. But according to here, maybe I can find it because it was pretty relevant. That's where the river is shown to have gone a different direction because of the direction of the offshoots. That's where they got cores. Not sure, something to do with as far as the ice got, glaciers got. Here it is. I believe he shows the Varvs. Something to do with the thickness increasing. So it's not as heterogeneous as I thought it was over here. I thought it actually had a pretty substantial change. But it is, there is a change in the Varvs, is what he's saying. But there's not a change in the rate of ice sheet retreat around the younger Dryas. So the water starts draining out this way at some point. Also, he pointed out something like Finger Lakes here. There's something just like it over here. Similar nature, possibly even like all the way across the whole thing and just covered. Said to be subglacial channels where high currents were flowing through those channels. Hudson Bay folded metamorphic rocks transported to Minnesota. So these rocks are brought to Minnesota. I forget where in Minnesota. Maybe over here along Lake Superior. But from here to over here, folded metamorphic rocks. He says there's no modern analog for the glacial lakes, the Great Lakes. water rushed out into northern Atlantic 8,500 years ago to 8,200 years ago as the final drainage, which happened twice. And it occurred within a year. All that water went out into the Atlantic. He pointed out it wouldn't look like a catastrophe. I'm not sure if this is the same video anymore. Wouldn't look like a catastrophe if you were like far away from the drainage point. Let's say this is like drainage out here, drainage. Like there's just drainage of the waters into here, like as the ocean starts to open. Like before, the Greenland was over here hanging out here, and the ocean crack wasn't like large enough. The expansion of the earth hadn't yet occurred sufficiently enough for separation to occur to then have an ocean bed to have the water go into. So it was just held up here until then, until apparently 8,500 years ago, when the water was able to drain the second time. Which made me, the second time made me think of Permian Triassic extinction as a second like major extinction in the process. Maybe like a lot of this stuff is dating towards even before then, like 400, 500 million years, suggesting it's very early on in the process. The water drains once catastrophically to northwest. So one of the times water here drained to the northwest over here, I believe it's here, catastrophically released water this way. Maybe out this way, and it just kind of like drained out into the ocean. But then the Baja California and et al., all of the parts of the islands that were over here that were just being shoved up and accreted to this region, like closed off. And that drainage point was no longer functional. So that then it like continued. Maybe something of that nature is what I was thinking. And then it also drained into the Lake Superior Basin. I didn't quite understand that one. That's another like catastrophic drainage. Maybe like once it reached it. And it only drained fully when through the Hudson Bay going out this way. Because of the opening of the ocean. And also probably just flowing out that way, but okay, I'm gonna stop there. This is long enough. I have another page of notes about the mid-Pacific, or the mid-continent rift. Is that what it is? Yeah, mid-continent rift. Maybe I can just... Yeah, it's just pretty much the dating of the magmatism is 1.11 to 1.082 billion years, and then 1.09 to 0.9 billion for sediment filling, and then 1 to 0.9 billion for compression and aborted rift. So whatever happened here, according to like technical reasonings, is thought to have been 1 billion years or thereabouts for the rift, mid-continent rift. So it's possible there was something of this nature again that was just there already, and the current went to it and around it, and like maybe even filled it in, like concreted it, made it less rifty. Current going this way, going around. It's straight across here. Maybe going up that way. Doing some kind of thing like this. On both sides, like down at a divide, like right here. Anything going up that way or down this way. Maybe down there. Like building like wings though that stack so that the current then goes down, over, and back. Also, and like cycles. Possibly it goes up this way too. Alright, I'll be back. See y'all later. Peace out.